every day, everywhere around the world. Millions rely on sign language. Yet, most of the world can't understand it.
Hello.
We are Compact Demon Hunters, and we're excited to present our real-time ASL alphabet detection tool.
The system utilizes a webcam to capture ASL gestures, processes these gestures using MediaPipe, and uses a trained machine learning model to recognize these gestures. These recognized gestures are then displayed as text on the screen and spoken aloud using Python text-to-speech, making communication more accessible for both signers and non-signers. This project is designed to help users understand people with disabilities who communicate using sign language. The biggest challenge was ensuring that the data extracted from MediaPipe contained all of the necessary information for reliable training by the random forest classifier, especially since the data was captured from a low-resolution webcam. Despite this, the system is capable of recognizing ASL gestures in real time, converting them into text, and even speaking the recognized text aloud for improved accessibility. By leveraging computer vision and machine learning, this tool helps bridge communication gaps between signers and non-signers.
And these are our project objectives. 1. To develop a real-time ASL gesture detection using computer vision and machine learning. 2. To enhance accessibility for communication between signers and non-signers. 3. To automate interpretation of ASL alphabet gesture for simplified learning.
Now let's talk about the key libraries and tools we used in this project. First, we used the OpenCV library to access the webcam, capture video frames, and process images. OpenCV allows real-time image manipulation, which is crucial for interactive application like ours. Next, we used MediaPipe, a powerful library for hand tracking, which allows us to detect and process 21 hand landmarks in real time. This helps us capture the essential features of each ASL gesture. For machine learning, we use scikit-learn to train a random forest classifier that can accurately classify hand gestures based on the landmarks detected by MediaPipe. To convert the recognized text into speech, we integrated a Python text-to-speech library that helps improve accessibility for non-readers or visually impaired users. We use tkinter for the graphical user interface, or GUI, which displays the recognized text and allows users to interact with the program. We also used Pillow for image processing, Pickle to save and load trained model, and Time to handle time-related events like gesture stability.
Our program consists of several key functions. Let's start with the start recording function, which begins the video capture process and starts recognizing gestures in real time. Similarly, the stop recording function stops the webcam and halts the recognition process. There's also clear sentence, which clears the displayed text on the GUI, and delete last character, which removes the last character from the recognized sentence. Users can also toggle mirror mode using toggle mirror function, making the webcam feed behave like a mirror. Other functions like process video and update sentence label handle the core logic of processing each frame, detecting hand gestures, and updating the sentence display on the GUI. We also have a function for handling camera selection and volume control for text-to-speech.
This is the brief explanation of the code. Now moving on to the main code 1, collect images.
In the collect images file, a for loop iterates over 28 times for our number of alphabetical characters as well as space and thumbs up. Once a user presses Q, they will break from the top for loop and enter the bottom, where 100 pictures are taken, and once all 28 classes have been captured, the windows will close and the program will end.
This is how we trained our model, or basically the collecting images process. Code 2, create dataset.
In the create a dataset file, a dataset is created from the pictures to be processed in the AI. Firstly, MediaPipe draws hands, and a for loop is iterated over every single folder in the data file as well as every single image in that folder. This program marks coordinates down for each hand landmark generated by MediaPipe and saves them into a data.pickle file, which we will process in train.test.split.
Code 3, train test split.
In train.test.split, the file generated in the previous program is then processed by the AI. If the data's length is 42, it is complete and therefore will be processed into the actual AI model. The model we use here is a random forest classifier, and once it is trained, it will be put through a prediction test, and if the score is satisfactory for us, we will save the file and move on to our final program.
Lastly, the actual program in code 4.
Next is our final program, which imports all these libraries, loads the model.py file generated in train test split, as well as initializing all of these variables. It also generates the tkinter UI on startup. When the hands are set up, they're set up with the exact same code as the create dataset file. Next will be our video processing, which adds the functionalities for all of the buttons as well as proper hand tracking to ensure that the proper hand is tracked and no other hands obscure it or take priority over it, as well as ensuring that nothing can be misconstrued as hands if they are too small. And next is our prediction logic. And if a data is complete, it will, with the length of 42, it will predict what character we are signing. If it is speak, it will initialize the text-to-speech program. If the character is space, it will add a space indicator. And if a character is a regular alphabetical character, it will generate that character onto the sentence. And these are the buttons and controls of our program. And lastly, on closing, everything will properly close to ensure that our program does not run into any problems.
Love you.
Now that we've discussed the tools and workflow, let's talk about the results and conclusions of our project. Our tool successfully recognizes ASL gestures in real time and translates them into text and speech. The tkinter GUI makes it especially easy for users to interact with the program, with features of starting and stopping the webcam, changing camera input, deleting characters one by one or clearing a whole sentence, and adjusting the volume. One of the biggest challenges we faced was ensuring the model's accuracy, especially when working with such low-resolution webcam inputs. We had to carefully process the data and ensure that the hand landmarks were detected correctly without any obscure pieces of data or any parts where the camera was blurred. In the future, we plan to expand the model to include more ASL gestures such as those that require two hands or more movement, improve recognition accuracy, and enhance the user interface for an even more intuitive experience.
Finally, let's quickly go over our self-evaluation. We believe that our project applies essential programming concepts such as conditional statements for gesture recognition, loops for processing video frames, and data structures like lists and dictionaries to manage landmarks and labels. Our code is well organized with clear comments and logical groupings of functions. Key sections are separated for readability, making it easier to understand the overall flow of the program. Lastly, these are the references, and ChatGPT was used to debug issues.
Bye.